Hey, it's Mr. Donahue again, this time taking a look at significant figures. So basically, are some numbers more important than others? Alright, so objectives. We want to understand what significant figures are and determine how many significant figures are in a number. We also want to understand what exact numbers are. And yeah, those are our objectives. Okay, so significant figures. What are they? Is there a difference between 1200 and 1200 with the decimal point? You betcha. Oh yeah, there's a difference. So let's start with the review of precision. So how exact are your numbers or your measurement? And that's pretty much your precision. What place value can you estimate to? Right? So what place value are you confident in? So if I had 12.045, that 5 is where my precision is. So it's a thousandths place, right? So which numbers are significant? Well, any numbers directly measured or estimated are significant. So if I had 12 centimeters written like this, there are 2 sig figs because I measured the 1 in the tens place and the 2 in the ones place. So those are significant. 12.0 has 3 significant figures because I was able to measure and estimate the 1, the 2, and the 0. So that would have 3 sig figs. So wouldn't all numbers be significant then? Aren't we measuring and estimating all the numbers we're writing down? No. Let me give you an example, okay? 12 versus 0.00012, right? Is there a difference there? Well, we didn't measure anything in those values. Those are zeros because we don't even have anything in the hundreds place. We didn't measure anything as hundreds. We don't have any hundreds. So, yeah, they're not significant. So these 4 zeros, not significant, which means just the 1 and the 2 is significant. So it's still just 2 sig figs. All right, so zeros to the left of the first non-zero are never significant. So you can always put zeros to the left of your number and it doesn't change the number. They're not significant. They're not important. Like this, 00148 only has 3 sig figs because I didn't measure anything as those zeros. We don't even have anything. We have less than that. We didn't measure that. Those are not significant. 0.000125 has 3 sig figs because these zeros, we don't even have anything for them. We didn't measure anything up to that. We have less than that, so they're not measured or estimated. They're just, zeros. They're placeholder zeros. So this only has 3 sig figs. Okay? So wouldn't all the numbers be significant? Still no. So another scenario, let's say we had 350 milliliters and we were using this beaker, this 800 milliliter beaker, and we had 350 milliliters, which would be like right here. So if it was filled up to about here, you go, hey, that's like, all right, well, I can measure. Here's 100. Those are my calibration marks, and this would be 300. So my calibration marks would be to the hundreds place, which means my precision would be to the tens place, which means I don't know what's going on in this ones place at all. That 0 that's there is a placeholder 0. I don't know what it is. I didn't measure it. I didn't estimate it. I estimated the 5 in the tens place, so that's important. But that 0 is just a placeholder 0. I didn't measure or estimate anything for it because it's beyond my precision. So you can only accurately estimate to the tens place, right, for this example. And the 0 in the ones place is just a placeholder because I can't put 35 because I got 350, and those are different numbers. All right, so we didn't measure and we couldn't accurately estimate the value in the ones place, so it's not significant. That 0, not important. So how can you tell which numbers are significant then? Because sometimes zeros are significant, sometimes they're not. How can I tell the difference? All right, well, this is what you do. First, determine the precision of the number. So if it has a decimal point present, then the precision is the rightmost number, including if it's a 0. So you got a decimal point, you go all the way to the last number that they wrote on the right, and that is your precision. If there is no decimal point, then the precision is the rightmost non-zero. So no decimal point, you go as far right to the first or the last non-zero. All right, so then you count all the digits from the leftmost non-zero and ending at the precision of the number. So zeros to the left aren't significant. 0 is going to start with the first non-zero, and you're going to count all the way to the right till you reach your precision. So there's a little Atlantic Pacific trick, which makes you need to know a little geography, just a little bit. All right. So if there's a decimal absent, right, the A, if it's absent, then you count from the Atlantic side from the first non-zero to the last non-zero. So you can count right to left, Atlantic to Pacific. And if there's a decimal present, then you count from the Pacific side from the first non-zero to the last digit, left or right. So let me show you what I'm talking about. So when I got 1200 written as such, well, there is no decimal point, right? There's no decimal point, so it's absent. I'm going to start from the Atlantic side and go right to left. So where do I start? Well, I start at the first non-zero and I stop at the last non-zero. So this one's going to be kind of straightforward. I only got 2 sig figs because I'm starting at the 2 and I'm going to go all the way to my last non-zero, which is just the 1. So there's only 2 sig figs. So decimal absent, I count from the Atlantic side right to left, right? Now, if the decimal point is present, I'm going to count from the Pacific side. So I'm going to start on the left side. And I'm going to start at the first non-zero. And I'm going to stop at the last digit, which is the 0. So, all right, well, that tells me I got 1, 2, 3, 4. This has 4 sig figs. Right, that decimal point is saying that I was able to measure all the way to the ones place, which means this 10's 0, I actually measured to be 0. I measured that as 0. So that's an important number. The 2 and the 1 I also measured. So I measured all those numbers. I got 4 sig figs. So let's take a look at another example. So I got this crazy number and it says miles. So determine the precision of the number. If the decimal is present, the precision is the rightmost number, including if it's a 0. So we got a decimal point, so it's the rightmost number, and it's 0. So this is my precision right here. Okay. If the decimal is absent, we do something different. It'd be the rightmost non-zero, but we got a decimal point. So that 0 in the ones place is our precision. Then it says count all the digits from the leftmost non-zero and ending at the precision of the number. So I'm going to, leftmost non-zero is this 1. So I got 1, 2, 3, 4, 5 sig figs. So that has 5 sig figs. Or if I wanted to do my Atlantic Pacific trick, again, I go, all right, well, my decimal point is present. So I'm going to start from the Pacific side, which is over here. I'm going to count all of them starting with the first non-zero, which is this 1. So again, I would start at the 1 and I'd end at the last digit they wrote, and it'd give me 5 sig figs. All right? So zeros to the left aren't significant, which is why we can just ignore these guys. They're not important. What about zeros with a hat on top of them? Sometimes you'll see a number like this with a little line over it. I call it a hat. What it's saying is that, hey, this is a sig fig. And the reason that they do it is because, well, they can't put a decimal point here because then they'd be saying that this 0 in the ones place is also significant, which it's not. So this is in those instances where you have a significant 0 in like the tens or greater place and there's no decimal point. So if you see a hat, that's telling you that that 0 is significant. So if I had something like this, I'm going to just write a bunch of zeros and then put a hat over this 0. It's saying I was able to measure all the way to this 0. So all of these numbers are significant, right? So these zeros, not sig figs, whereas these numbers are sig figs, okay? All right, what about exact numbers? Kind of sounds self-explanatory, but let's talk about them. Exact numbers have an infinite number of significant figures. They're things that we have defined. So example, 1 foot being 12 inches, we've defined that. We're defining a foot as exactly 12 inches. So it's not, all right, well, there's 2 sig figs. No, there is an infinite number of sig figs. It's 12.0000, so on, forever and ever and ever because we said it is, right? Or things like 1 inch being 2.54 centimeters. We've also defined an inch that way. We said 1 inch is exactly 2.54 centimeters. So there's an infinite number of significant figures with these conversion factors. Or 1 meter being exactly 100 centimeters. Again, that's an exact number, infinite number of significant figures. The speed of light we've defined as that. And counting numbers. Like if you're counting things, those are exact numbers. There are 28 students in the class. That is an exact number. You can't have a quarter of a kid. You can't have half a student. You can't do that. So this has an infinite number of significant figures. It's exactly 28. So let's practice. Let's figure out how many sig figs are in some of these numbers. So I'm going to put this up, and then why don't you guys pause it and see how you do, and then you'll get my explanation. So go ahead and pause it. I'll wait. All right, cool. So now let's check it out. So here we got a decimal point present, so we can use our trick from the Pacific side to the Atlantic side. So we're going to start at the first non-zero, and we're going to go all the way to the end. 1, 2, 3, 4, 5 sig figs. So we got 5 sig figs in this number, right? Because that decimal point and then the 0 is telling me that I estimated that tens place to be 0. So it's an important 0. All right, same deal. No decimal point, so I'm going to start at the Atlantic side and go to the end. So I'm going to start at my first non-zero and end at my last non-zero. So I got 1, 2, 3, 4 sig figs. All right, 200.0. So that decimal point is telling me that the 0 is significant. I measured that or estimated it to be 0. And the trick being decimal point present, start from the Pacific side. So you start at the first non-zero and you go all the way to the last number. So this will have 4 sig figs. All right, what about this number? Well, decimal point is present, so it's telling me my precision is this ones place 0, and I'm going to start at this 4. So I got 1, 2, 3, 4, 5 sig figs in that number. All right, 124 people. Well, this is a counting number, so that's going to tell me I have an infinite number of sig figs. It's an exact number. There are 124 people. So that's an exact number, infinite number of sig figs. All right, 0.000458 kilometers per second. Well, zeros to the left of the first non-zero aren't significant. Or I can remember my Atlantic Pacific trick and go decimal point is present. So I got to start at the leftmost non-zero and go all the way to the end. So I got 3 sig figs. All right, same deal here, 0.0100 seconds. Well, this decimal point again is telling me I need to count from the Pacific to Atlantic side, starting with the first non-zero. So I'm going to start with that 1 and go all the way to the end. So it's saying I measured the 1 in the hundredths place, and I measured the 0 in the thousandths place, and I estimated the 0 in the 10,000ths place. So this has 3 sig figs. All right, and this 9,001, no decimal point, so I can start from the Atlantic side at the first non-zero and go all the way to the last non-zero. So there are 4 sig figs in that number. All right, so don't let significant figures trip you up. All right, try to summarize. How do you determine how many sig figs a number has? And that's pretty much it. You need to know sig figs, So I hope you found this helpful. I'll see you in class. Bring questions. Get back.